Hello to my single linked list part 4. If you remember very well on my previous videos on single linked list part 1, part 2, part 3, we were able to create a single linked list structure in C programming language, because this tutorial is all based on the C programming language. And I told you guys that you can't build a real world application without single linked list. There are other linked lists like double linked list and circular linked list. They have tree, graph, binary search tree, and the rest of it. Alright, so we start with single linked list, and this is the 4th video. In our previous video, we're able to write a single linked list that use one function to iterate through the heap allocated memory of that node structure members and print each of those node structure members of data values to the screen. But today we are going to do something more fun. Instead of us having different node memory allocation created and connect them and start printing them, it's better that we have one single function that can insert node at the end and have a separate function also that can print those node at every given point we run the program. Okay, so this is going to be a form of using iteration to create the node and also to print those nodes. Okay, so enough of the chit chat, let's dive straight into action. So I will just change to lk underscore lt, which stands for linked list. Alright, you can see ls. These are our programs we have written so far. I will just run them real quick before we continue. So this is a part 1, which is just linked list. I press enter. You can see we did find to write a single linked list with just one structure memory allocated of node called head. Then we also have the part 2, which I need to add 2. That's the binary executable name. I press enter. You can see what we did so far. We're able to add second node, okay, which is allocating a memory in the heap memory and adding value to the structure of the member data of that struct node in the heap memory. Then we also have the single linked list, the 3rd video, which is the last video we made. We're able to use one function and integrate two multiple nodes. About, I think, this 6th node we have here, and each node have different data in one member of the node called data. Alright, so today we are going to do something more fun, which is what you need to do when writing real world application using the C programming language and also other programming language as well. So I'm going to do cp to duplicate the single linked list 3.c. I told you guys that we are going to be following this thing series upon series. So if you have not watched the part 1, part 2, part 3, you may not understand this part 4. Okay, so we just continue from where we stopped. So single linked list 4.c. What we're about to do, or what we're just doing, is duplicating the single linked list 3.c, okay, to renaming the duplicate to single linked list 4.c. I press my enter key, ls. You can see we have the single linked list 4.c on the screen. Alright, so what I'm going to do is to use the Vim editor to start writing the program single linked list 4.c. Okay, you can see the program is still the same with the single linked list 3.c. So we're going to do some modification here. You can see this program is totally 111 lines of code, but when we are done with this program, it will be very efficient and more professional, and the code will not be up to 111. Alright, this is the weakness of the program. The weakness is that here you can see we have so many structures of node like current 1, current 2, current 3, current 4, current 5, and depth, and even head. So doing all these things doesn't make sense. That means if I need to have 100 node structure allocating a memory space for them, I have to create about 100 structure of node. It doesn't make sense. So we are going to write just one function and put it in a loop that will create node at every given time that function is being called. Alright, so which means we are going to delete all this memory we allocate, like current 1, current 2, current 3, current 4, current 5, and how we were able to initialize or assign value to them, delete them as well, and now we're able to link them and also delete this single function loop we wrote that prints those node. Alright, and also delete all these free we did here. So we would start deleting. So I press I for insertion key, so I just have to do it very fast, so allow you to delete. So let me see how far it has gone. Okay, we are still in current tree, that's fine. So we still continue. Okay, I think we should be at the end. Okay, comment 1, I think this is the last one, so I just have to do things gently now. Alright, I think that's all. So you can see it's just very small now, so we have to delete all this also and leave only head. Alright, now that's it. You can see the program is now very small, just 25 lines of what? 25 lines of code. Alright, this is 24 lines of code now. Alright, so we start writing our program. So for us to be able to create multiple nodes when a function is being called, is that we have to write the function ourselves. So up here, every function must live above the main. Alright, so we are going to put it below the struct, so below here. So I'll press enter 2 times, go up 1 time. So whatever we write here is called, whatever function that you write above the main is called function prototype. So I'll just give a comment to that function. Okay, it's called prototype. We do this in C, hence your program might have error while running. Okay, so this function prototype, we're going to be writing 2 functions, one to create a node and the other to print those nodes, So I will say let them have a type of void, which means we can do casting if we want, or we can just leave not to return anything. We can just ignore returning anything, because void means that this is empty, it does not return anything. So I will say let this function name should be called add node at end. Most people call this insert node at the end. Alright, okay, or insert node at the beginning, but this will always is insert at the end. So I just prefer giving it the name add node at the end, so that you guys, like, we don't need to speak so many grammar, so things just get like simple and easy going for you guys. So this function will accept one parameter, which will be a struct, okay, of this same node above here. You can see this node here going to be the struct of this same node, which is struct node, and this struct node here we are passing will be a pointer, which means we are going to accept a pointer of struct node into this argument of add node at end. Okay, so once we're done with that, I'll put semicolon. So we need to add another function here, so I will call this print underscore node underscore data. So this will print the node data. So I also have to pass in a struct of that same node pointer. Alright, and that is it. So these two are called function prototype. So what next is to start the function declaration of these two. So function declaration will always live at the bottom of the main. Okay, so I will give a comment here for each of the function. I will say function definition of add node underscore at underscore end, open and close bracket, because it's just a function. Then we close this. Then we start writing the code. We start defining that function. So remember, the function is of type void, which means it returns nothing, or we can do casting if we want. And the name is add underscore node underscore at underscore end, and it accepts one argument into its parameter, which is struct, okay, of node of pointer. So what are we passing? We call it head. Alright, which is this created above here. That is what we're going to pass. Alright, this head. Alright, so we come down here. So once we are done writing this, we have to start writing the body of the definition. So I close the bracket. So every definition must have an open bracket, open curly brace, sorry. So this is the open curly brace. You can see this is the open, and this down here is the close curly brace. So in the middle of the open and close curly brace, we start writing our program. So I will create a struct of that same node of pointer, and I will call this current. I'll say equals to null. Alright, and that is it. I don't like giving space when I'm working in C, especially when using the malloc like this. I don't like giving space, and also here I don't like giving space. I'm initializing a variable. I don't like giving space. That's just my style. That's why you can see here. You can see what I did here. So current equals to null. I just believe it's more readable that way than those spaces you normally have. Alright, so next thing again, I'm going to create another struct of this same node, which is a pointer, and I'll call this temp. I'll say equals to again null. Alright, so once I'm done, I'll also create a variable called data. Alright, so that is it. So the next thing here is now to allocate memory for this current of struct node. Alright, so I will say current equals to open bracket struct, which is of node, struct node, and we are returning a pointer. So what are we doing? We want to allocate the memory space, so we use the function malloc. Alright, open bracket, malloc must accept a size, so we say we give a size of struct, okay, of node, okay, of node, sorry, and that is it, semicolon. Then the next thing is always good to check for error, so we use the if statement and say hence current is equals to null. That means we encounter an error. Alright, so we would like to get that error printed to the screen, so we'll know whatever error we have, and that will help whoever that is using our program to know why the program crashed, or even us after we are done writing the program, we can know where the error is coming from. So it's always a good approach to always get error feedback. So we say double quote, I will say error number %d. So every system has error number. Alright, if you want to see the error number in your system, for example, I do Control T to open another terminal. You can see it at the top there, make it a little bit bigger. So there is this thing called error number. Okay, error number, press enter. I think is error number space minus L. Okay, yeah, that's it. You can see all types of error we have in the Linux. They are up to 133 errors. I think so, yeah. So all these are different type of error. They mean different things. Alright, so any error we get will be coming from here. So if you are getting error from malloc, that is memory space, we do not allocate that memory space properly. We should have the error for memory space within here. Alright, within any of these error. So I just want to show you guys how to see for error. If you try it on system, it do not work, probably do not have the more utils installed, so you should just probably type super user do apt-get space install more utils, and once you install this app, once you are done installing it, then you can now type errno space minus L, and once you press enter, you should have everything on the screen. Alright, so that is it. Control D to close that terminal so that we can continue writing our program. So once we are done here, we start. So we want to get the string of that error, so /n. Once we get the string, we want to say the error number should be passed to the %d, which is this %d here. Alright, and after we get it from this error number, the next thing is that we want to get a string also. Alright, so the string should also tell us what the error number is all about. So this return of string error will go to this %s. Okay, I hope that is understood. Alright, so we press enter. The next thing is that we would like to free the memory. So first of all, we like to free head, because head was passed in here. Alright, so after we free head, then maybe we don't need to free head here though, we just need to free current. Alright, so we free current, so we don't need to free head here, we free current. Then the next thing is here is that we exit our program by using the exit function, which is failure. So when that is done, So this code here will only execute if current is equals to null. But I know current is not equals to null because current is allocated memory space. So memory space is always a number. Alright, so that will never be equals to null. But it should, in case it works, it equals to null, then we should have this error given to us so that we can know how to fix our problem. So once we are done with that, then the next thing is we have to say this temp here, temporary, we has no memory allocation, have to point to a head or a structure that has a memory allocation. So where do you want to point it to? We want to point it to head. We say temp should be equals to head, and that is very, very nice. Now temp is equals to head, then we can work with this. We can say we can use the do while loop here and say, first of all, we want something on the screen. So we want to do a printf that will say enter node, enter node number, enter your node number, enter your number. Okay, that is the number you want to save in there. So once that is done, we leave a scanf here. So the scanf here is getting something from the keyboard. There are other functions you can use, like fget string, or fget_s, which is fgets. But let's use scanf for now. So we say scanf, we say %d because we are getting an integer comma, then we'll pass ampersand, then we say data. So this will be stored in data. Then once that is done, the next thing we should say temp that is pointing to head should now point to the head membership of that struct node, which is data, and should be equals to the data, which is this data here that we have scanned value from the keyboard and save into. So once we're done with that, put semicolon to denote the end of that statement, of that code. Then after that, we'll now do temp, okay, should be equals to temp. So temp is equals to itself, where it's pointing at that address, where it's pointing at. Then I say point to the next, which is a link. Every node you created must have a data and a link. Link means an address, another memory node, heap memory it can point to. Alright, so once we are done with that, we are now calling a function called print node, okay, data. So print node will now take this head inside it. Alright, so after that we close this and we now use our while loop to say while temp, okay, is not equals to null, which it never equals to null. So the code up here we continue. Alright, so this is very, very simple and very, very straightforward. So this simple code, you see, we have only one current. So this current here will be reused at every given time the function is being called. It will always create a different node with this same name, but we will see them as the system will see it as a different node, even though it has the same name. Alright, so that is it. So once we are done with it, the next thing we're going to do now is to print it. So we need to write a function that prints. Alright, we need to write a function that prints. So we come here. Alright, so the next thing is I'll just give you a function here. We say function definition of print underscore node underscore data, open and close brackets, and that is it. So the next thing we start writing the function definition void print underscore node underscore data. Remember it accepts an argument which is struct node pointer, which we are passing what head. That's why here we have to pass in what head. Alright, so for us to use the head created in the main function, this head up here in the main function that is allocated its memory space, we need to pass it to this function. That's why I see we have to give an argument space here into this parameter, and we do the same also here in the print. You can see it here. So now we need a body. Alright, so in the open and close bracket is where we write our body. Alright, so Now what are we going to do here is that we also create a struct of node pointer using the same name called temp. Even though we use the same name here, temp, and we use it up here, they are not the same thing, because this when you write a function lives in the stack memory, while when you allocate a function, that lives in the heap memory. So anytime this function is called, this struct of node called temp is created, and when the function is done and exit, this disappears from the stack memory. All right, so null. So now once that is equals to null, so what else can we do is to print that, right? So to print that, we will say this same temp now, all right, should be equals to head. All right, then after that we can say while, all right, temp, so temp while temp, okay, is not equals to null, which it never equals to, because now it's pointing to a memory address which is head. Alright, so we close this and open curly brace. So we use the print function to print the data. Alright, so double quote, I'll put \n, I will say data saved. Okay, do %d. I'll put 2 new line here, and here we have to say temp pointing to data, and that's how we get the data printed there. After that, we have to say temp, okay, has to be equals to itself and point to the next link. All right, and point to the next link and semicolon. So when that is done, we are done with this code. All right, I'll press enter and close the curly brace. Now you can see how we are able to point. So at every time this is called, this points to the next. So what happened here is that we scan a value and save it here in data, and we assign the data to the temp, which points to the head membership of the struct data. Data is now saved inside there. So data can be any number. Then we now say that same temp of that pointing of, which is pointing to the address head, which allocated the memory space, which has a member of data and link. We now say to that temp pointing to its own link, then we call this, all right, we print that and also point to its own link. But the problem here with this program is that this might not give us what we want, yeah, because it has no way to link with the node. All right, so what we're supposed to do here is to say temp is pointing to link, and the link here should be equal to what? Current. So that's how we combine and join the node. So it's very correct this way. Then here we'll now do the linking when we are printing. Do you understand? Because at that spot, print node data is always called. You can see it's always called here. So once this is not equals to null, the program starts from the beginning again here and start going down. Once we reach here, it called the same function again, this one below here. All right, so this is the clean program. All right, so the next thing for us here now is to know how to now do the arithmetic on how this program will now look in the interface. So interface here, we have to come to the main function here and start doing that. All right, so what we're going to do in the main function here now is that I'm going to create a variable called count. All right, so we use that count, so we say int comma count. So this is just a variable in the stack memory of this main function. Remember, when you compile your C program, your CPU has a feature called program counter, which is also known as instruction pointer. It points to this main first and start executing everything in the main. So the program counter, your computer does not know that all this function prototype and declaration below exists. So it points to here. It's inside this main that will call those functions. So the program points to here, start from here, come to here, come to here, shake this error. Once the error is false, it's go down and continue running your code. So below here now is where we are now going to call the add node at the end. So now we say count. First of all, I would like to do a printf here to say I want something to be in the screen. So I'll just give one single new line and I will say enter number of node to create, and that is it. So the next thing I also use scanf, I will say percent %d, and I will say count ampersand count. So that will now set count to the amount what we want to count. Then after that, that should be a semicolon, not colon. Then after that, we are now doing an iteration using for loop. I prefer using for loop here because it will make things more easy and more understanding for you guys. So I will say int, okay, I should be equals to whatever value we pass into count, semicolon. I will say once I is greater than 0, and which is always true, because whatever number we give is what will be set, I will be set to, and once I is greater than 0, then it will iterate through the code and decrement I. So once I is decremented to be equal to 0, then the program should what exit. So in the body of the code here is what we now call the add node underscore at underscore end, and pass into it parameter what end, and close that. And at the end we close this, and this is just the program. Then at the bottom of the program here, we just have to free what head, so that we don't get a memory error. And at the bottom here also, which is this function here, we also have to free here, because at every time this is called, we also have to free what current. Alright, and that is it. Okay, so let's go run this program. You can see the whole program is now nice and good looking. Okay, so if everything works fine, we should have everything well running. Okay, so you can see you can pause the program as I am scrolling down a bit, so if there's any error we can come and fix it. But if you are typing as I'm typing, that's very good of you as well. So we just save this program. Okay, and guys, please, if you have not subscribed to my YouTube channel, please head over to my YouTube channel, all right, and subscribe. My YouTube channel is just https://youtube.com/@hackpace. It's called at hackpace. That's just my YouTube channel. All right, this is my YouTube channel. So this is the address. We just type it in your URL, take it to my YouTube channel. Or you can go, if you are watching this video from TikTok, all right, just click my TikTok bio, and in that my bio you will see a link. Click that link. At the bottom you will see YouTube. Click YouTube, and immediately you'll be redirected from TikTok to my YouTube channel. And please, as you go there, please make sure you subscribe. All right, that is the only way you encourage me. Okay, and again, for those of you that wants to learn, all right, make sure you contact me with 091321, or let me just put the Nigeria code, say +234. okay, I think this might make TikTok to ban my video, but I don't know. All right, but if you want to contact me, you can message me on TikTok. All right, because if I put my number here, they might ban my ban this video. Okay, so I will just compile this program first. GCC single linked list 4.c -o, then we do single linked list 4. So if there's any error, we'll see the error output. There is not any error, the program should compile very well. I believe that there is no any error. If there's error though, we fix it. So I press enter, and we have errors here. You see exit success semicolon. Okay, and so there are places. How many error do we have here? We say have error at 34 the head. Okay, that's an error. Okay, we didn't close the bracket, and the current equals to null is not spelled well. Yeah, those are most of the mistake I made, guys. So just correct those spelling mistakes. Those are just spelling mistakes, so let's correct them. So the first was come down current. Let me see where I spelled current wrong. Okay, here was the first error. Should be double arrow. That is the way of spelling current. So the second was where I free. Yeah, I free current. That was well spelled. And then the other place I free head. I think the other place was where I free head. Yeah, okay, I can see it. Yeah, so close the curly brace and put semicolon. So I think those are the pretty error we had. If there's any, we'll come and fix it. So Control P several times will allow you to bring back your previous type command or run command. So if I press enter, the program compiles. ls, you can see we have single linked list for executable binary. So if I do // single linked list for, if I press enter, we should have our program running. Now you can see enter number of node. Let me assume I want to create 3 node. I press 3 and I say your number. Okay, enter your number. Let me see, I say 20. You can say you save 20, data 0. So enter number. Okay, I say 30. You can say you save 30, data 0. Okay, that's fine. Say enter your number. I say 40. You can say you data saved 40, and that is it. Okay, so this program is running fine at every given spot. We are able to enter different node. All right, so how many node have we entered so far? Let me scroll up. 20 was 1, 30 was 2, 40 was 4. Then if it allows to enter this one, let me say here 50, that means the program is not running fine. We should end. You see 50 is still allowing us. Let me say 70 is still allowing us. So that this program is not working fine. It's not stopping. All right, so Control C and let's go fix why that is happening real quick. So we go down below here, and so remember the count was set. So when the count is set here, we should say this pointing to this. Once it's greater than 0, we are decrementing. Then I think where the error is coming from, maybe it should be here. All right, so let me just say them should be equals to them and pointing to link. So let's see if this is the error. If that is the error, then we have everything set and working fine. All right, guys, so yeah, so let's go on. We'll save this and we will compile gcc single link list 4.c -o single link list 4, and that compiles. So /single single link list 4. I will press enter. So let's say 3, and I say I enter 10, and it's working nice. See, there's no 0 anymore, so data save 10. Then if I say another one, I'll say 50. So data save 50. Then the last one, I will just say 80, and once we enter this one, it should exit the program, and that works. Data save 80. So we're able to create 3 node. Let's run it again. So // single link list 4. This time around, let me enter 5 node. So I press enter. That's set to 5. So first one I will say it should be 5. Data save 5. I say the other one should be 10. Data save 10. I say the other one should be 15. Data save 15, which is 3 now. I say 20. So this is 4, and the last one 25, and this should exit the program. Wow, so the program is now working very well, guys. So guys, if you like what I'm doing and you wish to support me, please make sure you give me a like on my YouTube and follow me up on my YouTube, and also my TikTok. Share this video to your friends, invite them, okay, because I'll be going live tomorrow by 8 o'clock in the night. All right, so if you're joining from any part of the world, you are welcome to my community to join as well and learn a lot. Okay, it's been educational hanging out with you guys. Bye, see you on my next video. Bye, which is the 5th one. Bye.